Hello guys, welcome back to Cafe at Simplify. And in the previous video, we've looked at something, we've looked at it, levels of measurements. And now these measurements, which which are taken, they are always collected. So in this video, we are going to look at data collection methods, then we go to sampling and we'll sum up everything that is inside. The exegesis is to bring out everything about sampling, the techniques, the advantages, the disadvantages. Yes. So data collection methods. In when we go to find out those statistics in the fields and all that, we need to collect this data. But what are the methods? So we see that we have interviews. Yeah, it can be one-on-one. It can be a panel like the ones we always hold at CTF. It can be via a phone call. Maybe the police is interviewing you. Yeah, getting a report from you. It can be through these online social medias, WhatsApp. It can be a written one. Yeah, yes, that is interviews. Then we have experimentation. You can go in the field, you do soil sampling, which soil type of soil is here, which type of soil is there, what can grow best in this place. Then we have what we call survey. Yeah, telephone, mailed questionnaires, personal interviews. Yeah, then we have questionnaires. Yeah, questionnaire as a method of data collection. You send questions, people answer even without your presence. Then they give feedback via that hard copy. Then observation, observations. You can go and observe. Yeah, say for example, you are looking at how markets run. Okay, that one could not be the best. How people run the daily activities in the markets. You go and observe what is the most trending business in the area. You observe, oh, when I set up this business, people will come and buy. Yeah, you see the need. People are looking for food everywhere. That means if you set up a certain hotel, a certain hotel restaurant, you get you get customers. That is observation. You scrutinize the place. Yeah. Then we have literature review. You read, you dig and excavate to the books and find out the information given. It can be online, websites, magazine books. Then curriculum veto analysis. Yeah, CV, somebody's CV can be a way of collecting data collection methods, and you get to know more about them. Then transcript analysis. So we come to sampling techniques. We see that sampling is the process of identifying the elements to be included in a sample from the population with similar characteristics. The process of identifying the elements to be included in the sample from the population with similar characteristics. That is sampling. Sampling is a process. We have sampling and a sample, but we also have a population. So a population is the entire area of study. It is like the universal set. That is what we call a population. Then a sample is a smaller part of the population with similar characteristics. So we have a population here. But now out of this population, if we choose, if this is the population, yeah, then maybe using cluster method, we are going to look at them. We come and choose only this one from the population. Then we call that a sample. It's a smaller part of the population with similar characteristics. So we've chosen all these ones which are small. Say these ones were different color, something like that. So a sample is a smaller part of the population. It should have similar characteristics. Then a population is the entire area. This is a whole population, the entire area of study. Then the sampling frame is a list of elements in the population under study. So when we list those elements that we are going to look at this element, you look at this, you look at this, you look at this. We are going to look at S3, S2, S4, S1, S5, and S6. That is what we call a sampling frame. It is a list of elements in the population under study. The diagram below shows the population with its respective sample S1 to S6. Okay. Now identify the best and worst samples and give reasons for your answer. So here the best samples, yeah, S3 is the best, followed by S2, followed by S4, followed by S1. The worst will be S6 followed by this, followed by a smaller one. Why is A3 the best? It takes a big part of the population, okay, and these ones respectively follow. Then this one does not have, it's not part of the population. So we see solution best sample is A3, takes a good portion of the population. Worst is A6, does not possess characteristics. So this one does not have the characteristics of the population. Okay. Arrange the samples from the best to the worst. So it will be S1, S2 here, S2 I forgot to indicate it there, S2, then S4, we don't have S3, the first one is S3, S2, S4, S, S1, then S5, and the worst is S6. Then we have to look at characteristics of a good sample. What makes a sample good? Yeah. Why do we need a good sample? Because we need to make accurate conclusions. Yeah. Characteristics of a good sample have similar characteristics of those of the population. So a good sample should have similar characteristics to those of the population. Yeah. It should take a large proportion of the population. Should take a large proportion of the population. So, but in this process, we always encounter some errors. Yeah. The first one is size of the population. Why is this topic important? Sources of errors, because it's going to help us to evaluate when it comes to sampling techniques, and we'll find out, whoa, why is this one the best sampling techniques? Because of this topic here, this subtopic here, sources of errors and reasons for sampling. They are going to help us in sampling techniques, and we will conclude at that. So, sources of sampling error, size of the population. The smaller the size, the higher the sampling errors. If the size you've used is small, the smaller the size, the higher the sampling errors. Why? Because you are getting a small sample to draw conclusions for the whole. You are getting a small population to draw conclusion for the whole population. Yeah, it's like getting only 2 students when they have got A's, and then you come and conclude, oh, lecturer so and so teaches very well because 2 people have A's, yet the class is for 300 students. Really? So size of the sample. The smaller the size of the sample, the higher the sampling errors. Then homogeneous distribution of the characteristics. Homogeneous distribution of the characteristics. The more even distribution of the characteristics in the population, the more even distribution of the characteristics in the population, less the sampling errors, and the less even distribution of the characteristics in the population, the higher the sampling errors. So you're looking at homogeneous distribution. How distributed is our data? But based on characteristics. So if it is more even, yeah, distribution, that means more even, it is more even something is consistent, yeah, that is more even in this respect. So more if something is more even in terms of characteristics, yeah, this and this, there is some level of consistency, then we'll have less sampling errors. And then if the less even or heterogeneous, where they have different characteristics, then we'll have higher sampling errors. That means if, say for example, it's a type of soil, you find here the soil is gray, is dark, there it is brown. So such an area cannot be good for sampling. Why? Because homogeneous distribution of characteristics is poor. It is different everywhere. Get a sample which is similar. Let's say if you are to pick, if you are to test how the lecturer teaches, yeah, how he lectures, use the samples of the average students. Yes, this is what we are basically looking at. Techniques used for sampling, which we are looking at sources of errors. Which technique are you going to use to sample? The more inappropriate technique used obviously will lead to higher sampling errors. Reasons for sampling. Why is sampling so vital? Before we draw those conclusions, before we call ourselves economists and data analysts, yeah, before we give the national GDPs and all that, we make conclusions and evaluations, we determine economic growth rates between countries. Reasons for sampling: to minimize the time, to minimize on the time of duration of conducting a research. Yeah, that is why we carry out sampling. Imagine if you are to find out how many people are infected with HIV. That does not mean you're going to go and sample everyone in the country. No, you can based on certain area. We say we're going to come to a district like Apala. Then we carry out and we say on 100 people we tested, these were positive, these were negative. So then we later draw conclusions. So we minimize on the time of duration for conducting the research study. It means you will not go testing everyone to ensure that the research study is cost effective and manageable. That's why we carry out sampling, because you cannot go and sample the whole population. So to ensure that the research study is cost effective and manageable. Then to minimize on the scarce resources necessary for conducting out the research, to minimize on the research resources necessary for conducting the research. Then to overcome physical impossibility of conducting research studies with a large target population. Physical impossibility of conducting research studies with very large target population. Imagine if you are to carry out your population in a mountainous area like Bondibuj, and you are to move house per house. Some people are located very far and all that, but you can use a sample, let's say about 50 people, and you find out how their level of education, and then you later generalize, you do conclusion, and that is what we're calling inferential what? If you are to recall, inferential statistics. Yeah, we say it is a branch of statistics that depends on sample statistics to make generalization about the population. Yes, so hope you watched the previous video, guys. A reminder, please like, share, and subscribe. Click the bell so that whenever I post something, you are at first hand to get the new videos and release. Yes, so um, to achieve the sample characteristics accuracy for the research study, which in turn shall be applied to the general population. The reason why we sample: to achieve the sample characteristics accuracy for the research study, which in turn shall be applied for the general population. That is why we carry out sampling. I hope I've explained explicitly this reason: to overcome the physical impossibility of conducting research studies with a very large target population, to achieve the sample characteristics accuracy for the research study, which in turn shall be applied for the general population. Then to enable closer observation of the population or characteristics using samples, to enable closer observation of the characteristics, closer observation population of the characteristics using samples. When you have gotten a sample, yeah, say, imagine if they were imagine if they were to test, say, for cancer, they have to test the whole body just for cancer. That would be hectic. It will be very costly. Yeah, the resources will be a lot, time will be a lot, but they'll just get a sample. After that, they will have a closer to enable closer observation of the population characteristics. So that sample will enable people to observe explicitly, clearly, give it time and accurately. That is the benefit of samples. So we come to sampling techniques. These are categorized measured into two: probability and non-probability sampling techniques. The probability sampling techniques include simple random. These are probability, stratified, cluster, systematic, and multi-stage. Yeah, we have the simple random, stratified, systematic. Yes, then CM cluster, CMSSSS. Yeah, we have cluster, multi-stage, simple random, stratified, and systematic, CMSSSS. Those are probability sampling techniques. So what about the non-probability sampling techniques? This non-probability, that means there is no improbability involved here. In these sampling techniques, we're going to look into the details. These sampling techniques run for probability. It means they all have equal chances of participating. Why? Because we're going to just pick randomly. That is in probability. So in non-probability sampling techniques, that means you're going to be focused. You're going to have a target. You're going to have a backup plan. You're going to have facts to base on, parameters to use, convenience. These include convenience, purposive, snowball. Snowball, I call it snowball because of the book I read. Yeah, and quarter. Hmm? So we have convenience, snowball, purposive, purposive, and 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 quarter. Yeah, CPSC Q, CPSQ, CPSQ. I believe most guys know CPS, so adding a Q isn't difficult. We have convenience, purposive, snowball, snowball, and quarter. Okay, is CPSQ. So what is simple random? We start with the probability ones. What is simple random? See that simple random is a technique that puts into account the sampling framework whereby each element has equal chances of being included in the sample. So in simple random, puts into account sampling framework whereby each element has equal chances to be included in the sample. This technique makes use of either simple ballot or lottery or random selection. Just pick randomly, or you use a ballot. Yeah. Procedure. How do we carry out this simple random? Obtain a sampling framework first from the population. Write names. For example, get a box in a class. We're going to vote who's going to be the class rep. Get a box, write names of the people who are going to be interested. Then somebody comes and draws, yeah, from the box. So obtain the sampling framework. Obtain the sampling frame first from the population. That is when we call people who are interested. Write the names or numbers to identify each element on a small piece of paper. Then put the names in a box and reshuffle. Check the small pieces. This will make sure that the information is not biased. Check the small pieces of papers. Then pick one by one. Then pick one by checking the box after each selection until the required number of elements is reached as per sample size. Note, this technique is used for identical elements of the population. Okay, let me give a better illustration. So we want to find out which type of insects are common in this area. So we'll just collect randomly the insects, we put them together. Then we pick. First picking, you find it's a white ant. Second picking, still white ant. Third picking, red ant. Then fourth picking, still white ant. Then you can draw conclusion that white ants probably are many or any other stuff. Then we have systematic sampling technique. Say the three S's. Yeah. So now we have systematic sampling technique. So this puts into consideration the kth element. So it is the probability sampling technique that puts into account the kth element of the population, where k is the skip interval given by this expression. So we see that k equals to population size, which is n, out of the sample size, which is s. Procedure: identify the sampling framework. Select the elements according to the skip interval, starting from the first item in the sampling framework until the required sample is reached. Note: this technique is mainly used on identical elements in order to estimate the kth item syndrome in the population that may result in sampling errors. So let me give a better illustration here. If the population is of 100 people and the sample size is 80, at a desired error margin of 5%, then skip the interval, then skip interval given by k. The skip interval should be any population size which is 100 out of sample size which is 8, and we get 1.25, which is approximately to 1. Here is if the sampling framework can be identified as follows: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 4 up to 50. Then the first 25 elements to be included in the sample as follows. So 1, 5, 7, 9, 11, and all that. That is skip interval. What do you observe? We've been skipping 1 because we've used this skip interval. That means we write 1, we skip 2, we write 3, we skip 4, we write 5. That is what we are trying to describe as a sampling technique, systematic. You can say I'm going to skip an interval 3 by 3. That means I'm going to pick the first child. Let's say it's a class. Skip 1, go to another one. Skip 1, go to another one. So this skip interval here, this value here, gives us by how much we're going to be skipping. I hope that's clear. Then stratified sampling technique. Stratified is a type of sampling technique that ensures that the population is divided into groups called stratas or strata, according to some identified criteria like gender, level of education, business size. Yes, okay, I was looking for this word here. Each group is referred to as a stratum, that is while the groups are called strata. Each group is a stratum, while the groups are called strata. So in stratified, we divide into groups according to some defined criteria. We can say gender, males come here, females come here, PhD holders go somewhere, yeah, and those who wish to get them like me in the future, like that, level of education, billionaires, and all that. So we come to note down something. This technique for stratified, divided into groups. This technique can be used in conjunction with simple random or systematic sampling. If the population of a certain class is 100 students, of which 60 are male and 40 are female, I see this is already, we are seeing a strata somewhere, grouping males. Then by Taros-Yamanese formula or Morgan's table, the sample size 80 can be determined from the population of 100. So if we have, now say we have 100 students, but we have 60 male, 40 females, but then we want a sample size of 80, can be determined from the population of 100, from which the ratios can be used to determine the sample size for male and female as shown below. Male 60, female 40. So sample size using 80 will be 60 out of the total, which is 100. Then times the sample size which we want times what? 80. That means how many males are we going to pick? Yeah. Then we also come to the female like that. The sum of these two should always be equal to the sample size. It means in a class of 100 students, and we are given 60 male, 40 female, we've chosen 48 males and 32 females. Why? Because our sample size, the total altogether, they were what? They were 80. So we use that. And that is what we call Taro-Yaman's formula homogeneous table. Procedure: identify the sampling frame for each category of students. Select the elements from each category by either simple random or systematic. We see that here there is systematic, where they have been grouped according to gender. Then we have what we call the last the last the second last probability sampling technique, cluster, because we also have cluster sampling technique. So in this cluster, this technique divides the population into groups alongside natural or geographical lines like Kenya, Uganda, continent C, Africa, um, Europe, and all that, or Western, Eastern, and all that. That is cluster. Yeah, each group is called a cluster. A cluster is different from a stratum in that a cluster has very many elements as opposed to stratum. Stratums are always usually small, but a imagine taking we have said the stratum. The cluster is different from a stratum in that a cluster has very many elements. This cluster, imagine taking a region as a cluster, western, northern continents. So clusters are usually bigger than stratums. Stratums, the small groups, female, male, yeah, based on a given sample size. Yeah, you don't say male of the whole continents or all different continents, females, no. That would be going to cluster type of sampling. Topics that may require use of multi-stage sampling include levels of literacy in Uganda, unemployment, proportion of different students in the public universities from local communities in Uganda. So here we are looking at multi-stage sampling. This technique can be used in conjunction with simple random or systematic sampling technique. Population size. Yeah, we've looked at all that table of estimations. So here we come to the last probability sampling technique, multi-stage sampling technique. This is a type of technique that puts into consideration selection of the sample elements at different levels and is used in conjunction with either simple random or systematic sampling. Multi-stage technique puts into consideration selection of sample elements at different levels and used in conjunction either simple random or systematic. So key notes to take from here: different elements at different levels and used in conjunction with either random or systematic. So for instance, if the research is to be conducted on literacy rates in Uganda, then samples can be taken from this, then district, then sub-county, and all that. So we are looking at different levels. These are the different levels. Then in conjunction with simple random or systematic. So finally, we come to the non-probability sampling techniques. These are not many, and we say they are CPSQ. CPSQ. Therefore, we have convenience. It's a type of probability sampling technique that does not require sampling frame and requires the researcher to take a strategic position in order to identify appropriate elements from the population to be included in the sample. Okay. I made an example of Gema University where they're doing software engineering. For instance, if the researcher is to undertake a study to address colors for female students at Bugema University, then the possible positions for data can be you can go at the main gate of the university or at the cafeteria, in the lecture rooms, or in the auditorium. So this convenience is at the ease of the researcher. You strategize and say, I'll position myself at the gold canteens. How many ladies come there? And say that day, then another day, how many females? Then you estimate. Okay, the gold canteens is measured used by the males or by the staff members and all that. So that is convenience type of probability sampling that does not require sampling framework, and it requires the researcher to take a strategic position in order to identify appropriate elements to be included in a sample. Then passive sampling technique. This is a non-probability sampling technique that considers elements in the population that possess data relevant for the study to be included. Though you hear the word purposive, that means you already have predetermined parameters. So that is what we are calling that possess the data relevant for the study to be included in the sample only. This technique does not necessarily require a sampling framework to be identified. For instance, if the study is to be conducted is on the financial performance of Gema University, after the reason I have used this university in my this research and drawing conclusions, then the respondents should either be administrators, departments, deans, and all that. Then we have snowball sampling technique. This technique is this technique. I don't know if I misspelled. This technique, a non-probability sampling technique that requires the researcher to identify at least one element that will lead to identification of another with similar characteristics from the population until adequate number of the population is reached according to the researcher's judgment. So, for example, this snowball sampling technique, you get one. It's like it can be used in criminal investigation. You get one, the first suspect, then the first suspect will lead you to another, then the other will lead you to another. So, even that is the example here. Probably identify at least one element that will lead to identification of other elements, but with similar characteristics that all of these move what they were in that bar at the same time when a crime happened to take place. Then the quarter sampling technique requires that the sample has identical characteristics to that of the population, like gender. And this technique requires that sample has identical characteristics to that of the population, like gender proportions, female and male. The quarter sampling technique. The keyword is identical characteristics. Identical characteristics. And we'll end with this. In a sample of 200 people, the female are 3 out of 4. Then we can get of who are female. Then male are a quarter. Then we get this. So entry of students on non-government scholarship in public universities according to quota system that puts into consideration the population of the different regions in Uganda. This is an example. So the next will be hypothesis, when I'll be taking through. Be reading ready to like, share, and subscribe, guys. Any more clarification, I'm available. Thank you so much. Bye bye, and have a nice day.